Hello everyone. A very good evening to you all. How are you doing?
Welcome to SPSVERSITY. I'm here to take the last part of our solutions chapter today. So in the previous class, we discussed about a couple of things like um, the Henry's law, Rawls law, how the deviations are seen from the Rawls law, and then we passed through some of the topics like the colligative properties. There are four main colligative properties like relative lowering of vapor pressure, elevation of boiling point, depression in the freezing point, and also we discussed about the osmotic pressure. That was how we ended the previous session. Hope everything is very clear to you. Today we are going to deal with the continued part of osmotic pressure. So I just want to recall the topic. Osmotic pressure is something when two solutions, either the dilute and the concentrated, or the solvent and the solution, if they are separated through a semi-permeable membrane, then the flow of the solvent from solvent compartment to the solution compartment is called as osmosis. And the one with the lower concentration will have low osmotic pressure. The symbol which we are going to use for the osmotic pressure is pi. So the one with the lower concentration will have lower osmotic pressure, whereas the one with the higher concentration will have the high osmotic pressure. Because we know that pi is directly proportional to the concentration at a given temperature. That's why greater is the concentration, greater will the osmotic pressure. Now, if you are keeping two solutions over here and they have the same osmotic pressure at the particular temperature given, then they are called as isotonic. Iso means same, tone, isotonic in the sense they have the same osmotic pressure. Then if they have the same osmotic pressure, what do you think or where do you think the uh, movement of solvent to the solution will be? There won't be any osmosis because they have the same concentration. Then you have hypertonic solution. You have two solutions separated by a semi-permeable membrane. The one with the lower concentration is called as hypo. That's because its osmotic pressure is lower, the concentration is lower compared to the other separated by a semi-permeable membrane that is called as hypo. And if you have to have hypertonic solution, then the one which you have over here, the osmotic pressure of that particular component is higher than the other which is separated by a semi-permeable membrane. That particular solution is called as hypertonic solutions. Okay. Now we will see where do we apply this osmotic pressure concept in our day-to-day life. The first one, if you're going to keep a raw mango, that's how your mom prepares pickles at home, right? Do you remember what she does first? She's going to take the raw mangoes, the small ones, and she's going to dip it in a container where there is excess of salt. So what happens? The salt is a concentrated solution. The osmosis is going to happen. That means whatever the content which is present in that inside that mango, that comes out from the movement of the solvent inside mango towards the concentrated solution. That's the salt solution is going to happen. That's osmosis. And because of which the mango pieces or the raw mango that is going to shrivel. Then this you might have seen in the movies when the hero gives a heroine a rose and she keeps in the fridge for a week, and or in the morning if you go to the flower vendor shop, what is going to happen? You see he's going to sprinkle water on all the wilted flowers which have been bought yesterday. So wilted flowers revive when you keep them in water, because the movement of the dilute solution, that's water, is going to the through the semi-permeable membrane, that's through cell membrane inside the cells. And also if you have the vegetables like a carrot or the beetroot which have become limp, they are shrunk. If you are going to place them in water for some time, then they'll become normal. This is because of again osmosis. And then if you dip, so you know that all the injections, they have the concentration of 0.9% NaCl, which is equal to normal saline concentration. If a blood cell is dipped in a solution which is greater than this concentration, then the osmosis is going to happen. So the cell has a concentration of which is equal to 0.9% saline concentration, and you are going to keep that blood cell in the higher concentrated solution. So the solvent molecule from, I mean to say, the blood cell, whatever the fluid is that is going to come out the movement of the solvent towards the concentrated solution, the blood cell will shrink. Okay, if it is the other case, if it is the blood cell is dipped in a concentration which is lesser than the normal saline concentration, then what do you expect? Then the movement of the solvent, the water inside the cell will happen. Movement of water from outside the cell that will move toward inside the cell, so that the cell is going to bulge. Okay, and then in case of people who take a lot of salt food, and that particular salt is retained by your body, that takes excess of water, so you see the condition called as edema, the puffiness. So if you press like this, if you press like this and your skin comes to normal, in the edema case it takes little more time to come back to normal. That's because of that puffiness, not puppiness, it's puffiness. And then so if you have how the soil to plant root, how the water is going to move to the plant roots from soil, it's by osmosis, and also the meat to kill the bacteria that's stored and in the salt solution, and all the fruits, if you order for a gut bud or something like that which contains excess of fruits, that fruit is already cut and that is preserved in the sugar solution. So sugar solution and also the salt solution, they act as natural preservatives. So they kill the bacteria. Now we have one more concept which is called as reverse osmosis. If you have seen in some places where the drinking water is kept, it is there will be some name plate, or there will be something written like RO purified water. That's reverse osmosis purified water. What is reverse osmosis? What is osmosis? Movement of the dilute solution towards the concentrated solution. The solvent from the dilute solution will move to the concentrated solution apartment. The second thing, how do you stop the osmosis? How do you stop this movement of the solvent to the solution? You apply a pressure on the solution so that the movement will be stopped. This is called as osmotic pressure. The pressure required to stop osmosis is osmotic pressure. Then, what is reverse osmosis? If you apply a pressure which is greater than the osmotic pressure on the solution compartment, for example, if you have here the solvent and the solution separated by a semi-permeable membrane, what will be the direction? This will be the direction of the flow of the solvent. Now what you're going to do here is, first, condition 1, apply a pressure. I'll take osmotic pressure as pi and the applied pressure is equal to P. When the osmotic pressure applied, when the pressure which is equal to osmotic pressure is applied, then this movement will stop. I'll tell the second condition, where the pressure applied is greater than the osmotic pressure. You are going to apply it on the solution compartment. The flow will be reversed. The solvent from the solution will move towards the solvent compartment through a semi-permeable membrane. So the flow of solvent molecule from the solution towards the solvent when a pressure greater than osmotic pressure is applied, this particular thing is called as reverse osmosis. Where do you use it? In the countries like UAE, where you have less amount of consumable water, there what they do is they do the reverse osmosis. They have the RO plant inside somewhere in the sea, where they are going to purify the salt water from the sea. Now, what is this reverse osmosis? You are going to remove the salt content or remove the impurities from the salt water. How do you do that? You have the fresh water and you have the salt water that's kept in a container which is separated by a semi-permeable membrane. Here the semi-permeable membrane used for this particular purpose is cellulose acetate. Now, when the pressure which is greater than osmotic pressure is applied on the solution side, that's the salt water side or the concentrated side, the solvent from the salt water goes towards the fresh water. That's called as reverse osmosis, leaving behind the impurities. so that the fresh water is continuously taken out and the salt water is continually fed into this chamber. So the salt water gets converted to fresh water by reverse osmosis. This is called as desalination of seawater or salt water. This is a major application of reverse osmosis. Now, let's move on to the abnormal molar mass. What is molar mass? The mass of 1 mole of a substance in gram per mole is called as, in grams, the mass of 1 mole of substance in grams, that's unit is gram per mole, is called as a molar mass. And now, how do you measure the molar mass? In the all the colligative properties, if you remember, when you rearrange the equation, you got M2 at the end, isn't it? This is the molar mass of the solute. This is when you calculate using the colligative properties. And if you calculate it, sometimes the actual value might be different from that of the theoretical value. Why is that so? This is because some of the solutes, when they are put into solution, they undergo dissociation, they break down. And some of the solutes, they undergo association. When put in the solute, some of the molecules are going to combine. And some of the solute or some solutes may not undergo association, may not undergo dissociation. So they will be retained as they are. In those cases, the calculated molar mass, that's the theoretical molar mass, as well as the practically obtained M2 value, both will hold the same. If the solute undergoes either association or dissociation in the solvent, then you experience abnormal molar mass. What is abnormal molar mass? Any molar mass value which deviates from the regular value, either higher or lower. You can take both the extremes. Just like if you're normal, that's called as normal weight. If you are having extra weight or if you have less weight, both are considered as abnormal situations, right? The same way, the molar mass which can be either higher or lower than the calculated one or the theoretical one is called as abnormal molar mass. And we have a factor called as Van Hoff factor. This decides whether a solute undergoes association or dissociation in the solution. So, if you take KCl, when you put this into water, this is a solid. When you put it into water, it becomes K plus and the Cl minus, aqueous. We define the colligative properties as, these are the properties, which depend on the number of solute particles. So before putting into the solution, it was just 1 mole. After putting into the solution, this has broken down into 2 moles. And we have the formula for Van Hoff factor. I is equal to normal molar mass divided by the abnormal molar mass. What is normal molar mass? This is the theoretical one. Abnormal mass is a practical one. Or you can also define the Van Hoff factor as number of moles of particles after association or dissociation in the solution divided by number of moles of particles before association or dissociation. This is how you find out I value. Okay. Now, in this case, how do you calculate I? I is equal to, let me write it. I is equal to number of moles of solute, that's before association or after association will be on the nominator. So after association it is 2, or after dissociation, this is a dissociation. After dissociation is 2, before dissociation is 1, so its value is 2. I value, if it is equal to 1, then the solute behaves normally in the solution. If I value is greater than 1, the solute undergoes dissociation in the solution. And if I value is lesser than 1. For example, if you take the benzoic acid C6H5COOH, 2 molecules of benzoic acid, when put into the solution, they undergo association. It forms a dimer. If it forms a dimer, how do you calculate the I value? I is equal to number of moles after association or dissociation, that's just 1 mole, divided by number of moles before, that's 2, which is equal to 0.5. This is lower than 1 or lesser than 1. So this particular solute undergoes association in the solution. So I value is really going to help to find out whether a particular solute undergoes association, dissociation, or behaves normally in the solution. And whenever we apply any equation for the molar mass calculations, we have to multiply all those values by I, where I is a random factor, so that the theoretical and the practical ones, they agree with each other. Okay. Yeah. So this is the end of the topic. I think I have covered almost all the topics in the chapter solutions. We'll be going ahead with the questions. Which of the following units is useful in relating the concentration of the solution with its vapor pressure? It's not vapor pressure, it's vapor pressure. Sorry, I'm checking my mobile just to see. Yeah. Is anyone watching me? If you're watching, if you like the videos, you can always like and subscribe to the videos. Yeah, here we go. Go ahead. So what do you think? Which of the following units is useful in relating the concentration of the solution with its vapor pressure? Whenever we say vapor pressure, what do? We apply the Henry's law or the Raoult's law, and we say the vapor pressure is directly proportional to mole fraction. So what is the unit? So what is the quantity which we are referring to? It's the mole fraction. So the correct answer will be option A. Okay, we'll go ahead with the next one. Yeah. This is the dissolution of solid in a liquid. On dissolving sugar in water at room temperature, solution feels cool to touch. Under which of the following cases dissolution of sugar will be most rapid? Sugar crystals in cold water, sugar crystals in hot water, powdered sugar in cold water, powdered sugar in hot water. Where do you think the dissolution of the sugar will be most rapid? It feels cool to touch. Can you see this? What do you mean by that? After dissolution of the sugar in water, it's cool. That means it's endothermic. It is taking up heat, taking in heat. So it is an endothermic reaction. In case of endothermic reaction, the dissolution, I'll write it in case if you are referring to this, dissolution increases with increase in temperature. The forward reaction is favored according to Le-Chatelier principle. Now what you're going to take? The dissolution should be maximum, so you have to increase the temperature. So either it should be option B or C, powdered sugar in hot water or the sugar crystals in the hot water. But again, you remember powdered sugar dissolves easily, so it should be the powdered one. Okay, let's move on to the next question. At equilibrium, the rate of dissolution of a solid solute in a volatile liquid is? This is the question. How do you do this? What is dissolution? What is crystallization? All these meanings. The dissolution is when you dissolve the solid in the liquid. They have said, say you dissolve a solid and this becomes the solid which is in the solid form, and here the solid is in the liquid form or in the aqueous form. So you are going to dissolve a solid in water. Solid to the same aqueous conversion, this is called as dissolution. You are dissolving the solute. And then solid to solid conversion, that's aqueous, which is dissolved, that is converted into a solid. This is called as crystallization. So whenever you say you are at equilibrium, the rate of dissolution of a solid in the volatile liquid will be equal to the rate of crystallization. So the correct answer would be option C. The next question. A beaker contains a solution. A. Precipitation of substance A takes place when small amounts of A is added to the solution. So A is. What do you think the answer is? If you're looking, you can always post your answers in the comment section. A beaker contains a solution. So you have a solution. There are three cases. You are going to add A. If it dissolves, the first condition is if it is dissolves. It's not a concentrate, it's just a concentrated solution. You can dissolve some more, or it is also called as unsaturated. The solution is not saturated though. And then you are this whatever the solute you are going to add that doesn't dissolve, that just goes and settles down. This is called a saturated solution. You cannot dissolve more salt at that particular temperature. And if it precipitates, then it's called as super saturated solution. So the correct answer would be option B, which is called as supersaturated. Maximum amount of solid that can be dissolved in a specified amount of a given liquid solvent does not depend on temperature, nature of solute, pressure, and the nature of solvent. What do you think the answer is? Right answer would be. So you're dissolving, see the system, you're dissolving a solid in a liquid. If you're dissolving the solid in the liquid, both are least affected by the pressure values. Pressure is applicable when you say the gases. Liquids and the solids are not compressible by the application of pressure. These are least affected by the value of pressure. So the correct answer would be option C. Low concentration of oxygen in blood and the tissues of people living in the high altitude is due to. What is the correct answer? So, if you apply Henry's law over here, we know that greater is the pressure, greater will be the solubility. That means pressure is directly proportional to solubility. Low concentration of oxygen in blood. What do you mean by that? Why is it low? Low concentration is because it's less soluble. If it has to be less soluble, since solubility and the pressure are directly proportional, there should be low pressure conditions. So when you go to higher altitude, because of the lower atmospheric pressure, the amount of oxygen which gets dissolved in the blood will be less. That leads to a condition called as anoxia. Considering the formation of braking and the strength of the hydrogen bond, predict which of the following mixtures will show a positive deviation from the Raoult's law. Methanol and acetone, chloroform and acetone, nitric acid and water, phenol and alanine. So what do you think the answer is? Okay, let me go ahead with one. So we'll go with the first option first. We know that the nitric acid and the water, any acid when it is mixed with water, it gives exothermic reaction, because of which it shows a negative deviation with the from Raoult's law. But if you take into consideration the break and the strength of that, so in case of pure methanol, what is that? CH3OH. These are hydrogen bonded. The molecules are hydrogen bonded. And also, and if you add the acetone, these hydrogen bonds get disturbed. Okay, so this is like you have AA molecules which are hydrogen bonded to each other, and you add B. This B goes and sits in between, so it is going to interrupt the bonds which are already there. Now what happens? Between methanol and the acetone, there will be interactions which are weaker in the mixture compared to the original components, that's methanol and the acetone, which will lead to a positive deviation from the Raoult's law. So AA type of interactions and BB type of interactions are stronger than AB, that's after mixing. So we have a question over here. Calculate the amount of, 214.2 gram of sugar syrup contains 34.2 gram of sugar. Calculate the molality and the mole fraction. We are given with 4 options. How do we proceed? So what is given? The mass is given. I'll write it to here. Mass is equal to 34.2. Okay. Then number of moles of sugar. How do you find out? Calculate molality. What is the mass of water? Sugar syrup they have given. So mass of, what is the formula for molality? If you have to calculate option 1, I mean to say the question 1, molality is equal to number of moles of solute divided by mass of solvent in kg. So you need the mass of solvent. So the mass of solvent is equal to 214.2, that's a sugar syrup, minus this one. This will give you 180 gram. Now you convert it to kg, which is equal to 0.180 kgs. Now how do you find out the number of moles of solute? Number of moles of solute, or you can calculate the number of moles of water. If you have to, yeah, since the sugar, this is sucrose, if you calculate the molar mass, this will be 342 gram per mole. You calculate the number. First, molality will apply over here. Number of moles of solute, that's 34.2 divided by 342, that's mass over molar mass, divided by 0.180. This will give you, let me calculate, 0.1 divided by 0.180. This is going to give you approximately 0.555 molal. So the correct answer among these would be this one, because A we got as 0.555. Now what you have to find out? Mole fraction of sugar. Mole fraction of sugar is equal to, that's XS, I'll write, number of moles of sugar divided by number of moles of sugar plus number of moles of water. Number of moles of sugar is equal to mass over 34.2 over 342. Number of moles of sugar is 34.2 over 342 plus number of moles of water is equal to mass over the mass of water, mass over the molar mass. So how do you get it? Mole fraction. Number of moles of water is, yeah, mass of water is 1000 grams divided by mass, by 18. It should be number of moles of water That is 180. They have given 180 grams, right? So that should be not 1000. It should be 180. They have given 180 grams. So that will give you almost 0.0099. So the A would be the right answer. Calculate the amount of oxalic acid required to obtain 250 ml of semi-molar solution. What is semi-molar? How do you find out the semi-molar solution? What are you going to do for this? So the molarity. How do you write molarity? How do you calculate it? Semi-molar. Okay, let's calculate the mass they have not given. You can calculate the molar mass. That's I'll take it as MR. Two hydrogens, 2 times carbon. That's 12 times 2 is 24 plus 4 times 64 plus 2, 18. That's going to give you the molar mass would be approximately around 128 if you calculate that. So you need a semi-molar solution. How do you find it out? The volume. Volume is equal to 250 divided by 1000. That's 0.250 capital liter. So you have the molarity, semi-molar solution. What do you do for this? Weight of the solute is equal to 0.250 over 128 divided by 2. That's going to give you 15.75. That's the answer. The first answer. 15 gram of methyl alcohol. This is dissolved in 35 gram of water. What is the mass percentage? How do you do? This is pretty simple. I'll just tell you the way. Mass percentage of methyl alcohol is equal to mass of alcohol divided by overall mass. That's mass of alcohol plus water times 100. That's 15 divided by 15 plus 35. That's 50 times 100. If you calculate that, that will come out as 30%. So the correct answer would be option A. 1.82 grams of a metal required. So they have given you the mass 1.82 to prepare the volume 32.5 ml of normal HCl dissolvent. What is the equivalent weight they have asked? We know that. How do you find out the equivalent weight of this one? We find out it by using the formula equivalent weight of metal is equal to equivalent weight of HCl, which is required for dissolution. Then what is the equivalent weight of the metal? So 1.82 grams. And what is this? 32.5. This is a volume divided by 1000. You convert it to liter. 1.82 divided by its equivalent weight. Equivalence. So you multiply this and you rearrange this. So equivalent weight is equal to 1.82 multiplied by 1000 divided by 32.5. If you calculate this, it would be around 56. So the correct answer would be option C. The vapor pressure of a pure liquid A at some temperatures, say 310 degrees, is 120 torr. This is the unit of pressure. The vapor pressure of this liquid in the solution with liquid B. In the solution, the vapor pressure is 72 torr. Calculate the mole fraction of A in solution if the mixture obeys the Raoult's law. How do you find it out? So the vapor pressure of pure liquid, that's P naught, 120 torr. The vapor pressure of this liquid in the solution with the liquid B, the vapor pressure is equal to 72 torr. What's the mole fraction? So mole fraction, we have P is equal to P naught times X. P is 72, which is equal to 120 times X. So if you calculate, X is equal to 72 divided by 120. If you calculate that, it's 0.6. So the correct answer would be option D. The degree of dissociation of calcium nitrate in dilute aqueous solution containing 7 gram of salt per 100 gram of water at 100 degrees Celsius is 70%. If the vapor pressure of water at 100 degrees Celsius is 760 millimeter of mercury, the vapor pressure of the solution. So what they have given us is the degree of dissociation, and they have given you the mass of salt per 100 gram of water. So what do you do? The calcium nitrate, you can find out the molar mass. Calcium is 40 atomic mass, nitrogen is 14, oxygen is 16. Taking this into consideration, you can find number of moles of water. I'm taking number of moles of water is equal to mass over molar mass. Mass is 7.0. Molar mass, when you add this calcium nitrate, I'll calculate it. Yeah, it comes out as 168 gram if I'm not wrong. This is present in 100 gram of water. And the degree of dissociation of this particular thing is 70%. So what is the degree of the dissociation? So what is the total number of particles then? If it is 70%, total number of particles if you are going to have is equal to this number of moles, okay, 70%. What is 70%? 70 over 100 into how many ions it is going to give. Each calcium nitrate, when it is dissolved in a solution, it is going to give 1 Ca2 plus ion plus 2 NO3 minus ions. So the total number of moles is 3. Let me calculate this value. 0.0875. Now, what is the moles of solvent? This is number of moles of salt, it should be. I'll take it as salt. This is number of moles of water. They have given 100 moles of water, and the molar mass of water is 100 grams of water in molar mass, 100 over 18. This is going to give you 5.55. The vapor pressure is given. You have to find out the vapor pressure of the solution. So how do you find out this? P naught minus P divided by P naught is equal to W2M1 divided by W1M2, or you can always say this as this is directly proportional to mole fraction of the solute divided by X1. So the P naught value, if the vapor pressure of water they have given 760 minus P divided by 760, which is equal to X2. X2 is nothing but the number of moles of solute. Okay, if you find it out, you can always say this as N2 divided by number of moles of solute, the mole fraction of the solute, sorry. This is directly proportional to this value is directly proportional to the relative lowering of vapor pressure, that's delta P over P naught, is directly proportional to or is equal to X2. X2 is nothing but N2 divided by N1 plus N2. If you substitute this, N2, number of moles of solute, that's the number of moles of salt, 0.0875 divided by 0.0875 plus the number of moles of water, that's 5.5. When you do this, what is the value of P you are going to get? Substitute this. See, it's 748.3. So the correct answer would be option A. But if you look at the question, 760 millimeter of mercury, you're adding a salt and definitely the vapor pressure is going to decrease, and the vapor pressure will not decrease by addition of just 7 gram of water with the greater value. So 1492 is very double, almost double, and 3472 is almost half, and 74 is by 10. So these values are not accepted. Only vapor pressure reduces by a small fraction. So option A should be the right answer. The vapor pressure of a solvent, they have given vapor pressure of solvent is P naught, 20 torr, where its solution, that's 17 torr. What's the mole fraction of solvent? Okay, they have asked what is the mole fraction of the solvent. How do you do? P is equal to P naught times X. P is 17 divided by 20 is going to give you the X. So what is that? If you calculate 17 divided by 20, that's going to be almost around 0.85. So the correct answer would be option C. Methyl alcohol and ethyl alcohol have the vapor pressure. They have given the vapor pressure. If 16 gram of methanol and 46 gram of ethanol are mixed, the mole fraction of methanol in the vapor pressure. Vapor is, you are asked to find out the vapor mole fraction of the vapor phase. How do you do this? So I'll take it as the methyl alcohol and the ethyl alcohol have the vapor pressure. So vapor pressure of methyl alcohol is 88.5 millimeter of mercury. Vapor pressure of ethyl alcohol, M stands for methyl alcohol, E stands for ethyl alcohol, 42.0 millimeter of mercury. Okay, and the masses, weight of the methyl alcohol is equal to 16 gram. And you can find out the molar mass of this anyhow. And the weight of ethanol is equal to 46.0 gram. Now you can find out the MR over here. This is C2H5OH, and this is methyl alcohol and ethyl alcohol CH3OH. So if you find out, let me find this out fast. Mass is, molar mass is 32 over here, and here it's 46. So how do you find out? The mole fraction of methanol in the vapor. Okay, let me find out this first. We have the formula P total. We need P total, right, to calculate. So P1 plus P2. What is P1? P1 naught X1 plus P2 naught X2. What is P1 naught? P1 naught is nothing but P 88.5 times what is mole fraction of the first component? Mass over molar mass divided by 16 by 32 plus the mole fraction of the other, 46 by 46. This is the first component plus the second component, 42.0 times again the 46 divided by 46 divided by the whole fraction, 16 by 32 plus 46 by 46. If you do this, let me write the values here. I will be getting P total. Quickly calculate if you are watching this and help me out so that I can skip this. Okay. It comes out as P total 57.44. Don't forget to write the unit, though I forget. Now, in the mole fraction in the vapor phase, how are you going to find it out? Mole fraction in the vapor phase is equal to P total is equal to X into P1. This is what we are going to find out. So it's for the first component, mole fraction of methanol in the vapor phase they have asked. So I can take it as Y also in the vapor phase. So let me substitute. Let me substitute the value and find out. So the way in the this thing P1 by P total it seems. So what is P1? You have to multiply. P1 is equal to nothing but P1 not X1. If you do that, you're going to get the first fraction, that's 88.5 times 16 by 32, whole thing divided by 16 by 32 plus 46 by 46. The whole thing divided by the P total is 57.44. I'm writing this value over here. There is no space. So multiply this. This is going to be 0.51. 51. Yeah, we have it over here. So all the three values are almost near. You can see that. So find it out properly. So the answer would be option C. The next question. The vapor pressure of benzene at 80 degrees Celsius is lowered by 10 millimeter when 2 gram of the non-volatile solute is added. So vapor pressure is lowered. So delta P they have given 10 millimeter of mercury. Mass of the solute added is 2 gram. And the is dissolved in weight of W2. Solute is W2. Weight of the benzene is 78.0 gram. So vapor pressure of pure benzene, that's they have given you the P naught value 750. So what you are supposed to find out is M. So how do you do this? Delta P divided by P naught is equal to W1 M2 W M, yeah. If you can, I think I'm right over here. W2 M1 divided by W1 M2. So if you arrange this, the decreased by 750, which is equal to W2 is 2.0 M1. The molar mass of benzene is 78. W1 is 78 multiplied by M2. Yeah, let me calculate. I think I'm right here. If you calculate this, 2 times 750 divided by, sorry, help me guys. So you are finding M2. You take it over here. 2 times 750 divided by 10, approximately 10. So it is 75 times 2, nothing but 150 gram per mole. So the correct answer would be option A. Calculate the molar elevation constant. You are supposed to find it molar ebullioscopic constant. Water evaporates, temperature they have given 100 degrees Celsius. With the absorption of 530 R, they have given 2 calories. And the absorption of delta H, heat, 536 calories. How are you going to do this? What is the formula you're going to apply? So to find out this, you're going to apply the formula Kb is equal to R. Okay. Kb is equal to R square divided by the heat. So RS2 calories they have given times the temperature square, 100 degrees Celsius, you have to convert it into temperature, 373 square. Temperature, I'll convert it to, since it's in calories, you have to convert this. Sorry, in degrees Celsius, you have to convert it into kelvins. Divided by heat, that's 536 into 100. We'll calculate this value. Sorry, 1000 per kg. So 0.519. So that's the value. The correct answer would be option A. We are going ahead with the next question. 0.15 gram of a substance dissolved in 50 grams of the solvent boiled at a temperature higher than this. Calculate the molecular weight of the substance. Weight they have given W2 0.15 and M2 they have given 15, sorry, M1. I'm sorry, extremely sorry. Weight of the solvent in the second case also they have given W1 is equal to 15 gram and the elevation in the boiling point delta T B is equal to 0.216 degrees Celsius, which is equal to Kelvin only. Calculate the molecular weight of the substance. They have given Kb value that's equal to 2.16 degrees Celsius. So how do you find out this? You have M2 is equal to 1000 Kb W2 divided by W1 into delta TB. Apply these values 1000. Kb is 2.16. W2 is 0.15 divided by W1 is 15 into delta TB is equal to 0.216. Tens out, tens out, tens in. So if you multiply this, what is the value you are going to get? Approximately 100. So the mass will be 100. Unit is gram per mole. The latent heat of fusion they have given. You have to find out molar depression constant. So what is the relationship you have? Molar depression constant, that's Kf is equal to R Tf square divided by, yeah, 1000 into the heat. That's latent heat of fusion. So it's R as you can take it as 8.314, but here it is in calories. So you have to take 2 calories into the temperature. 80 Celsius at 0 degrees Celsius, you have to convert it into Kelvin. 273 square divided by 1000. Latent heat of fusion is 80 if you calculate this. It will be 1.863 degrees Celsius. So that would be this one. Yeah. Osmotic pressure of a sugar solution at some temperature. The atmospheric pressure is given and the temperature is given. Determine the concentration of the solution in gram mole per liter. How do you calculate that? What they have given? Osmotic pressure 2.5 atmosphere. Temperature 24 degrees Celsius. You convert it into Kelvin by adding 273 plus 24. That's going to be 297 Kelvin. And then okay, the gas constant value, that's 0.0821 liter atmosphere per Celsius. So what is the question? Osmotic pressure, concentration of the solution. They have asked the concentration. We have pi is equal to CRT. Pi is 2.5. C you don't know. R is 0.821. Temperature they have given us 297. If you rearrange the concentration, you are going to get it as 0.1025 liter per mole. Sorry, mole per liter. I'm sorry. $1025. So the correct answer would be option C, I guess. Yeah. So we have solved a couple of questions from today's session. So that ends the chapter solutions. So keep all the feedbacks in the comment section. Thank you for watching and supporting. Keep always supporting us. Thank you.